So, we have spent the previous two lessons taking an in-depth look at creating scientific graphs using R. Today, we want to improve on our skills of graphing, but in order to do that, we have to take a somewhat indirect approach. Namely, back in the day, we talked a lot about various types of data, namely whether some piece of datum is a character string or a logical value or a numerical value. Today, we're going to be learning about yet another type, and this type is called a factor variable. So we are going to be learning about factors, and the reason why we are learning about factors is because they solve a very important problem that arises when creating plots. So let us take a look. We begin by loading the tidyverse, and today we are going to be taking a closer look at the forcats package. That is the package within the tidyverse that allows one to work easily and conveniently with factor variables. So just to take stock of all the packages that we have discussed during this course, let us take a quick look. We have discussed the dplyr package. That one has support for basic data manipulation like select, filter, arrange, mutate, and the like. Today we're going to be discussing forcats. ggplot2 is what we have been discussing for the previous two lessons of creating graphs. Reader is the package that has readDlim, readCSV, readTSV, and the rest. Tibble has support for tibbles, and tidyr has functionalities for reshaping data, like with pivot longer or pivot wider or separate those functions. Really, the only three packages we haven't looked at are the stringer, lubridate, and per packages. Out of these, stringer offers many utilities and convenience functions for working efficiently with character strings. You are more than welcome to explore it on your own. In fact, you have the knowledge by now to understand what its functionalities do, so I encourage you to explore it. The same is true for the lubridate package, which instead of working with character strings, is a package to make it convenient to work with date variables. So if you want to work with dates, then lubridate is your friend. Finally, the per package implements a set of efficient programming techniques that often go under the umbrella of so-called functional programming. I'm not going to be discussing that here, but in case you are taking the advanced course in the next semester on data analysis and statistics at Linköping University, there we are going to be making heavy use of the features of the per package. But alright, with that, let us turn back to our original topic for this lesson, which is factor variables. To illustrate the problem that we're going to be solving with factors, let us load a data set of temperature data, and you can see the link to the file at the bottom of the slide. Then we load the file. It is a comma-separated value file, so we specify readDlim with the delimiter of a comma, read in the file, assign it to the variable temp, and then see that it is actually a simple table with 12 rows and 2 columns. The 12 rows each correspond to 1 month, and I can scroll all the way down so that you can see that indeed the final entry there in the first column is December, so the months are ordered from January to December. And then in the second column, it is called temp_C, which is just means temperature in Celsius degrees. And it is monthly average temperatures averaged over months, and not just months, but also many years, I think 3 decades worth of data or so, in the city of Linköping in Sweden in this particular case. So we see average monthly temperature data. Straightforward, we just want to create a graph of these data. So let's see what we can do to actually visualize these monthly temperatures. Here is one straightforward way of doing so. So we just feed in the temperature data to the ggplot function, and then we define the aesthetic mappings as month going along the x-axis and the temperatures going along the y-axis. And we use geonPoint, which means that every row will be displayed by a single point, which means that for every month we'll have a point displaying the average temperature for that given month. The final line here is just a cosmetic thing, namely if we didn't specify an alternative label for the y-axis, it would just default to whatever the name of the column was that we used in the aesthetic mappings. So the y-axis label by default would read as temp_C, which is a bit ugly and unprofessional, so we override that using the final line by tweaking the appearance of the y-axis using scale y continuous, as we learned about in the previous lesson. Alright, so I think we can all agree that this attempt at visualizing the data is a bit of a disaster. Why is that? Well, notice that the months are not sorted chronologically. Instead, they are sorted alphabetically. This is the default behavior with character strings. So when we feed character string data into ggplot and R more generally, then the default sorting is always alphabetical. In other words, what we need to do is somehow move away from the alphabetical sorting and try to be able to sort these months in some other order that follows some chronology. How can we do that? We can actually do that by inserting one very simple extra step into this pipeline right before we feed the data to ggplot. This is the line that we need to feed in. And if you look at the graph, now the temperature profile follows exactly the same pattern that we would expect, because if you look at the month labels, now the months are actually sorted nicely in chronological order. What does this extra inserted piece of code do? Well, we mutate the month column to be equal to as_factor of month. So what we're doing is somehow converting the months into something else using this function as_factor, which we have not yet seen before. So let us discuss what this actually does. In order to do that more efficiently, let's just separate out this very simple first bit of the program. And if we look at the output, we see that we get much the same table that we had before, but there is something a little strange if we look at the type information. In particular, notice that month, instead of being CHR for character string, has the type of FCT, which stands for factor. So what the as_factor function does is convert the character strings into factor variables. In fact, it will do the same with logical or numeric variables as well, so those can also be converted into factors. Okay, but what does that actually mean? Well, factors are variables which have a particular finite set of possible values, for example, the 12 different months. But there is an ordering defined on them, and the ordering is often referred to as the levels of a factor. So the first level of a factor is the first in the ordering, for example, January in our case. The second level would be February, and so on until the 12th level, that is December. The as_factor function converts quantities into factor variables, but it does something clever and in the meantime, namely, it automatically determines the levels of the factor in the order of appearance in the table. So, in other words, when we say month should be equal to as_factor of month, then we look at the month column, we convert it into a factor and automatically set the factor levels in the order in which the months appear in the table. And because this table happened to be such that the months were already in correct chronological order, this means that the factor levels are also already set to be in the correct order. Therefore, we didn't need to do anything else. This little adjustment already adjusted things, and therefore the plotting facilities inherited the factor levels. And if I go back two steps, here, that is why the months along the x-axis are now in the correct order, because they follow the levels of the factors. Just for the sake of completeness, one should mention that this kind of behavior, where the factor levels are defined in the order of appearance within the table, is only true for character strings. By default, if we would like to convert, say, a numerical type to a factor, then the levels follow the numerical order of the individual entries. So in other words, the numerically smallest entry will be the first level, the second smallest, the second level, and so on up to the highest value and highest level. But in this case, since we were converting the month column into a factor, and month happened to be a character string, the levels simply follow the order of appearance of different levels in the table. What could one do if the months, say, were not sorted in this table in chronological order to begin with? Say if they were in alphabetical order instead of the order from January to December. In that case, we can still reassign the levels, but we have to do it by hand. Fortunately, there's a convenient function to do that for us. It is called fct_relevel. And what fct_relevel does is it takes a factor or a character string as an input, in this case the months, and then, as you can see, we specify by hand the order of the levels. So January's first, February's second, and so on and so forth up to December. And if we do that and assign the result of this transformation to a variable that I call temp fact for factor-based temperatures, then you can see that the month column is again a factor here, and the levels will follow the order that we've input by hand, so it will be in the correct order. So what this means is that if we were to use this new temp fact variable to create the exact same plot that we were doing before, it would just work, because by now in that new table the months are already sorted in the proper order using the factor levels, and therefore, as you can see, the temperature data appear with the months in the right order. So just to recap as for where we are at with factors right now, the two most important functions that you should know are as factor, and as factor is a function which converts other types into factors. Moreover, if we are converting character strings into factors, then their levels will be automatically assigned in the order of first appearance inside the table. And the other function that you should be aware of is fct_relevel, which you can use to reorder the levels of a factor variable manually. Additionally, it will automatically promote character strings into factors. Careful, again, this is just a side note, but be aware that if for whatever reason you would like to re-level the factor levels of a numerical variable, then you first have to convert those into factors. In other words, first you have to apply as factor to the numerical variable, and then you can reassign the levels using fct_relevel. Not that that is a situation that would come up very often, but just for the record, I am mentioning that right here. There are just two small comments to be made. First of all, R has a function that is called as.factor. As usual, that is the original version of the function that is found in base R, and the tidyverse has the as_factor version of that function, which has various improvements on it. So for example, the as.factor function does not order character strings in order of first appearance. So in general, as_factor has small improvements over as.factor, therefore I do not recommend that you ever use as.factor, use as_factor instead. The other comment is that actually these two functions are enough to get you practically anything that you would want to achieve using factors. Now, it is true that the forcats package has several functions that allow you better convenience in achieving those things. You can check out the package and its functions. All of those functions start with fct_, by the way, so they follow that nice pattern, just like the fct_relevel function. But while those are convenient, you don't really need them to achieve what you want to achieve, and I wanted to illustrate that that is the case through a simple example. The example relies on the Galapagos land snail dataset, so we load it again in the usual way. Here is the table, we are very familiar with that already, and let's see what we are trying to do with it. Namely, we want to plot the shell shape distribution of each of the species using box plots. So here is the simple program that will do that. We feed the snail's dataset into ggplot. We specify the aesthetic mappings as species identity going along the x-axis and the shapes going along the y-axis. And here is the graph. Nothing wrong with this graph. You can see that there are 7 different species. Each of them have a given distribution of shell shapes. There is just one issue with this plot, that again the species are in alphabetical order along the x-axis. Now, while there's nothing particularly wrong with that, it would be nicer if the species were ordered based on their shape. So in other words, the species with the smallest shape parameter would come first, and then they would follow an increasing order. Now, these box plots emphasize the median of the data, and again, the median is the point that separates the bottom half of the data from the top half of the data. Those are the thick lines within the boxes. So because these box plots emphasize the median, it makes sense to try to sort these species based on their median values, so we are going to take a look at how to do just that. To do so, we don't really need to learn anything new, we just need to combine our existing pieces of knowledge in a clever way. So to begin with, let us create a new column in the table called median shape. So what we do here is first of all group the data by species, and then tag on a new column using mutate and we call it median shape, which simply computes the median of the shapes within each species. We do that within each species because we have grouped by species first. So in other words, in this table that we will get, every row that corresponds to one particular species will have the exact same entry under median shape. And then finally we ungroup these data. The output from this table is right here, and nothing unexpected. Notice that there is a fifth new column called median shape in this dataset. And also notice that those rows that correspond to the same species, for example, Ustulatus, all of these 4 rows have the exact same value of the median shape. So that is the same at every row where there is Ustulatus, and that will be the same for all the other species, of course, as well. So the median is specific to the particular species that we are talking about. But now that we have this median shape column at hand, we can arrange the rows of this table based on that column. And we can just do that by piping the result of the previous computation into the arrange function, which then will reshuffle the rows of the table to follow increasing order in median shape. And then we can convert the species column into factor using the asFactor function. What will this do? Well, let us look at the output of the table. Since we have sorted by median shape, the smallest median shapes come first. That happens to belong to the species Unifasciatus. So all the Unifasciatus individuals will be first in this table, followed by whatever species has the second smallest median shape, and so on and so forth. But now, because if you remember, asFactor converts strings into factors and does so assigning the levels in the order in which they appear in the table, Unifasciatus will be the first factor level in the species, which, by the way, now is a factor variable, as you can see. And then the next species, and the next, and the next. And therefore, if we pipe this table on into a ggplot function, doing the same thing that we were doing before, then the resulting plot that we get looks like this, which is again the same as before, except that the species have been rearranged along the x-axis. The species with the smallest median shape is first, and the one with the largest median shape is last, and it is in increasing order all the way through. So this concludes this small example on using factors to sort values by increasing median. And it also concludes our lesson on factors more generally, and it also concludes the course that we have been doing on data analysis and visualization using R. So all I can say is that thank you very much for your attention. I hope you did learn something useful here, and I wish you the best of luck analyzing your data using R. And if I may offer that piece of advice, never forget to have fun while doing so.